Can anyone remember the standard form? A, C, something like that. I'm going to give you a hint. It starts with Y equals. Y
Okay.
X plus C. Alright, Y X plus C. What was that sound? Oh wow, really? Okay, C was the Y-intercept. The right ring a bell. C is the Y-intercept. Now the Y-intercept of any function, any graph, guys, is the point where the graph cuts or goes through the Y-axis. Do we remember the Cartesian plane? We did it quite a lot in, we used it rather in trig, right? We have your Y-axis and your X-axis. Okay, we are going to draw some graphs as well. But the Y-intercept, just in case you have forgotten what that means, is the point where graph that's the Y-axis. Guys, we're working with functions, with graphs, we're going to be working with coordinates a lot. So when we did work with coordinates in trig, so you should be kind of okay with it. If you have a point on the Y-axis, sorry, this one, on the Y-axis, the X value of every single point on that axis, on that line, will be 0. Okay, so the X value of the Y-intercept will always be 0, and then the actual Y value will be C. So we're going to do an example or two, so that you can see that graphically as well. Then M, can anyone remember what M was? The gradient, yeah. So M was the gradient, which is basically the slope. Alright, so I can put slash slope. Means the same thing, but the proper term is gradient. Now guys, if you have a positive gradient, so I'm going to write here, if M is greater than 0, that means M is a number, a value that is bigger than 0, that's positive, right? Then your line is going to have this kind of shape. It's going to be an increasing line. So a positive gradient, it's going up, right? Positive. If your gradient is negative, it's obviously going to be the other way around. It's going to be decreasing. So it's going to be a line that's going down. So the actual steepness of that line can differ depending on the value, but that's just the basic shape. Right, there was a formula that we could use to calculate the gradient. Can anyone remember what that formula was? Honey? Almost. Change in Y is over change in X. It's very easy to get confused with this formula, guys, because when we're writing coordinates, it's always X first and then Y. Right, so I think people are often inclined to put the Y first always, because that's so drilled into your mind, X first and then Y. But for gradient, it's always change in Y over change in X. Yes, you can write delta Y over delta X if you want, you know. Probably. You can do some research. Alright guys, another way you could write it is you can also say it's the Y value of the 1 point minus the Y value of the second point over the X value of the 1 point or the first point minus the X value of the second. You can change the order around of which Y value you put first, alright? So you can actually do Y2 minus Y1, but then the order of your x values must be exactly the same. All right, so if you're doing y2 minus y1, you have to do x2 minus x1. We're going to do an example now, just calculating gradients, which you can see. Okay, are we fine so far? Just quickly, for example, find the gradient of AB if A is the point 1, negative 2, and B is the point negative 4, 6. No, we don't have to do it. We're just going to calculate the gradient, yeah? I just want to make sure we all are okay with working with this formula. All right, so you can definitely do this in your head science fiction, but I am going to write out all the steps. So I'm going to say the gradient of, guys, let's use AB as a little subscript. Right, sometimes you're working with two different lines and then it's good to just identify which one is which. The gradient of AB is equal to, so guys, you don't have to write the formula down every time, okay? You don't even have to write it down at all, you can just remember it, please. Now, if I'm starting with point A, right, that is my first point. Then I'm going to say the y value of A minus the y value of B, but then I have to do the x value of A also minus the x value of B. All right, so you have to put the same, you have to put the y value and the x value of the same point first at the top and the bottom. So I'm going to say negative 2, right, minus 6. So you're always subtracting that second value over, so those are the y values, right? Y value of A minus y value of B. Over x value of A, which is 1, minus the x value of B, which is negative 4. No, you'll get the same. Okay, are we fine with that, guys? And then just work that out. What's negative 2 minus 6? Negative 8, and this is 5. Negative 8 over 5. If you did it the other way around, let's quickly think, what would we get? We would get 6 minus negative 2, which is 8 at the top, right? And negative 4 minus 1, which is negative 5 at the bottom. So you would get the same final answer. Okay, you want me to write that down? You can do 6 minus negative 2. So that's now the y value of B minus the y value of A. However, because I started with the y value of B, now I'm going to start with the x value of B as well. So negative 4 minus the x value of A, and then we'll get the same. Yeah, you're not showing how you represent the thing. Okay. So you can add it. You just put the three points. Okay. All right, guys, so that is how you would calculate the gradient if you have 2 points. So 2 points are just given. All right. You do need 2 points, guys, in order to use this formula to calculate the gradient, because you have to have 2 x values and 2 y values. All right. You can't use that formula if you only have 1 point. All right, now to draw a straight line. There are different scenarios, but the easiest way, do you guys remember the 2 methods that you learned last year? The dual intercept method, does that ring a bell? And then the gradient intercept method. Okay, so we're just quickly going to summarize it. Which is why we are revising. Okay. All right, dual intercept method, guys, dual means two, hey? So that means we're going to calculate or just find two intercepts and pop them and join them. All right, and then that's our line. So for this one, we're going to find the y-intercept. That's always the easiest one to find. How do we find that again? It's the c value, all right, in your equation. So I'm just going to put that on the side. So I mean, fine, you kind of just look at the equation and it's there, all right? That is your y-intercept. Then you're going to have to calculate the x-intercept. Unfortunately, the x-intercept, you can't just look at the equation and immediately know what it is. You do have to do a calculation. Not a hectic calculation, so you might be able to find it. Can anyone remember how you find the x-intercept? Yeah. It's named y equal to 0. Right, so in your equation, guys, right, your equation is y equals like 2x plus 4 or whatever. You make y equal to 0, and then that's going to give you an equation with x that you must then solve. And that is then your x-intercept. Okay, all that's left after that is to plot those 2 points and connect them. Right, draw with a ruler, draw a straight line through them, extend past those 2 points, and put arrows on the sides or on the ends. All right, so that will be the next step, is to plot these points. I'll just use PTS to plot these points and connect them. I'm going to do an example for here using the dual intercept method. On this graph or a straight line graph. Alright, so for example, if we have, let's do y equals 2x plus 4. Yeah. So guys, this year we're going to do 4 different graphs, alright? Up until this point, you've only done one, which is the straight line graph. You've done straight graph as well, but it's not part of the section. So you only know how to draw a straight line graph at the moment, alright? But at the end of this whole chapter, if I give you an equation, you will be able to recognize from the equation what type of graph it is. Okay, they all have different identifying properties or characteristics or whatever. So for this one, it's always that it's in the form y equals mx plus c. So basically, guys, you are going to look for just having an x to the power of 1 in your equation.
Thank you.
I mean, it depends on the equation itself, and ask you here and if I graph and ask the equation. But yeah, if they're given you the equation of a graph and you must do it, you will have to be able to identify which type of graph it is first. Okay, but seems a bit unnecessary at this point because obviously that's straight line graph. Okay, guys, so we're going to find the y-intercept. What is my c value? What is the constant term here? Get that? 4. All right, so the y-intercept is 0 and 4. The c value, all right, is 4. So that's going to be the y-intercept to the graph. Now for the x-intercept, I'm just going to write here again, make y equal to 0. You don't have to write it down when you're doing it yourself. So guys, you can obviously write 0 equals 2x plus 4, right? Because y must now be 0. But I just prefer the thing that I'm solving for to be on the left. I'm just going to swap it around like that. Right? Is that okay? I don't want to confuse anyone. Y is 0, and that is equal to 2x plus 4. Okay, I've just written the 2x plus 4 in the front equal to 0. That's an easy equation to solve, right? That plus 4, we're going to move it to the other side. It's going to become negative 4. And then we must divide by 2. The x is negative 2. Alright, the x value of this point is negative 2. What is the y value of this point? 0. Hey, we even said y is equal to 0. Okay, So for an x-intercept, the y value will always be 0. It's on that line, on that x-axis. Any y value on that point or on that axis value is 0. Okay, all that's left now, guys, is to draw a continuous plane, y-axis, x-axis, plot those 2 points and connect them. Do that on your own, please. We're going to, yeah? What? I don't remember what it was. No, you never done. Oh, I'm not going to remember. Okay. A lot of just like that now. Yeah, you can. What I've done in the past is they lost the points and I just like highlight the points so that I know those are the ones. There's good with other ones on the end of like every. Yes, on both. Yeah. But the thing is just there are some cases. Okay, are we done? Not yet. Bending the line across the point. And there's the first phase. You don't have to use only draw one block, but you do have to label it. But if you draw like 2 different straight lines, then you must label it. But when you mean label the point, the okay, let's take a look. Here we go. I drew my bottom y-axis, my negative y-axis a bit shorter, but you obviously could have drawn it longer, doesn't matter. Yes. That is not what I was wondering. Sorry. Well, I mean, I'll pull the bag. Probably just to get you guys used to how that works. So guys, you don't have to put the actual like values on the axes. All you need to do is you need to label the points that you have plotted. Okay. Yeah, you just want to. No, it doesn't have to be. I usually try to draw mine after, but sometimes the values are very big. I don't think you were live to. I mean, you were. No, I just think whoever it was, one have to make it active. Yeah. Yeah, it's just like take it. Yeah. But it was the first time I wanted to make it, but we never had this. Or to see this. Okay. Wow. Then you then say energy. So that's it. But energy. When you say how to do that. All right, so guys, if you had drawn multiple lines, thank you, on the same set of axes, right? Later on, you might have to draw a straight line and a parabola on the same set of axes, right? Or a parabola and a parabola, whatever. Then you would have to label an actual graph, all right? And what you would do is just either on that side or that side, you would just write the equation of the graph. So y equals 2x plus 4. We're going to talk about function notation in a little while. Let's go back to that. So then sometimes they might call one graph x and another graph g. Then you can write x next to the one and g next to the other one. But in this case, guys, since we only do the one graph, you don't have to label. So there's no, you won't get confused with which line and which line, because there was what you do have to label, guys, your 2 points. Please, with the coordinates, please don't write a 4 and a -2. Often in TESOL exams, they say label or label the coordinates of the intersection with the axis. Okay, so let's get used to that. There's always use 4 coordinates. All right, so that is dual intersect method. It is definitely the easiest method, all right? But in some cases, you won't be able to use it. I'll show you now. Do we have any questions on this example, this method? No, okay. Method 2 is the gradient intercept method, which, guys, I suggest you only use this method if you absolutely need to. Okay, so I'm just going to make a little note here. Use this if all right, thank you. Let's write that down, please. Okay, so you're going to use that, or this method rather, if the y-intercept is 0. Okay? Because guys, the point 0, 0, the origin, right? Can we just look at this Cartesian plane here as an example? If I have a point there, the origin, right? That's the point, 0, 0. That is your y-intercept and your x-intercept at the same time, right? So if you have a y-intercept of 0, then you're not going to be able to get another point as your x-intercept. Because if your y-intercept is 0, that's also your x-intercept at the same time. You need 2 points in order to draw a straight line. So if your y-intercept is 0, you can't get another point as the x-intercept. All right, so I'm just going to add that. Use this if the y-intercept is 0, 0, because that is also the x-intercept. So we do need 2 points, right? Okay, so I'm going to write the steps down quickly and then we're going to practice it. So the first step is going to be exactly the same as in the previous example. You're going to find the y-intercept, which is going to be your c value. So guys, just to clarify, you can use this method even if your y-intercept is not 0, but I don't recommend that you do. Okay, because when you are drawing a straight line for marks, you get a mark for your y-intercept and a mark for your x-intercept. Okay, so you have to calculate your x-intercept if there is a different one. If you are using the gradient intercept method for like this graph, for example, this one here, right? And I'm going to show you now. You have to do like a counting thing using the gradient. You probably wouldn't have gotten this x-intercept by doing your counting. So you would have another point on the line, but you wouldn't get a mark for that point because they'll be looking for the mark. Okay, so you can use this method for any, but only use it if the y-intercept is 0. Okay, so I'll show you now. Find the y-intercept, which we know is the c value. Then you're going to write the gradient. So write m as a fraction. No. Guys, if your gradient is already a fraction, obviously you don't have to again write it as a fraction, right? I just mean if your gradient is like 2, you're going to write it as 2/1. Okay, instead of just 2. So that would be step 2. And then you are going to use the numerator to count up or down, depending, right? If your numerator is positive, you're going to count, what do you think? Up. If your numerator is negative, you're going to count down, right? Positive is up, negative is down. So using the numerator to count up or down, and the denominator that is a word. It's an odd word now. Denominator. All of a sudden it sounds like it's not right. Oh, yes, no. Stop. It's not. The count to the left or right. Again, guys, if the denominator is positive, what do we think? Is positive this way or that way? To the right, eh? Yes, so that's one, all right? So if your denominator is positive, you go to the right. If it's negative, you go to the left. Thank you. But you are going to count from the Y-intercept. I'll show you now. It does sound a bit odd or a bit confusing possibly when you are just reading the words. Okay, it's simpler when you're looking at an actual example. So you're going to use the numerator to count up or down and the denominator to count to the left or the right from the Y-intercept. Then plot a point where you stop counting. Stop counting. And then that's going to be your second point. Right? So then you're going to connect the Y-intercept and that point. So a straight line through them. So connect these points. Okay, we're going to do an example with you guys. Are there any questions on just what I've written there so far? No, we're fine. Okay, sorry, I'm just life is a bit of an annoyance. All right. Example. All right, we're going to do the graph of x2 -1, -2/3x. Okay, that's right. All right, thank you. Guys, that is a straight line equation, right? It is in the form y equals mx plus c. But do we notice that there is no c? There is no constant term. What does that mean? C is 0. So you can use a different color just to put a plus 0 there, but obviously they'll never give you that plus 0. Okay, that 0 will never be used. Okay. So now do we agree that the y-intercept is 0? Okay, so this means y-intercept is the point 0, 0, the origin. So that means that it is also the x-intercept. So that means that we have to use gradient intercept. If you try to find the x-intercept there, right? Imagine how it's recognize that the y-intercept is also the x-intercept. You don't have to write this down. I'm just going to show you. You would say, okay, to find my x-intercept, I'm going to make y equal to 0. So I'm going to say this whole thing, negative 2 over 3x is equal to y, which is now 0. And now you're going to say 0 divided by negative 2 over 3, which is what? 0. Okay, so do you see? You'll get the same point for your x-intercept. And then you'll think, oh no, I only have 1 point. What do I do now? All right, then you're going to use your gradient. So guys, you don't have to do that x-intercept calculation. I'm just showing you that is also the x-intercept. All right, so now we're going to do our second step here. We've already identified that the y-intercept is 0. We're going to write our gradient as a fraction. Guys, it's already a fraction. Do we see that? If it was a negative 2, you would write it as negative 2 over 1. All right? If it's negative 6, or let's say it's positive 6, you would write it as 6 over 1. Okay, if it's a whole number, you just put it over 1. We have to have a fraction, guys, because remember, what is the gradient? Change in y over change in x. Okay, so we have to have a number at the top to do our up or down counting, and we have to have a number at the bottom to do left or right. Okay, that's why we're writing it as a fraction always. Okay, so what I'm going to do here, I'm going to just rewrite negative 2 over 3. So guys, you can decide what you want to do with that minus. You can put it at the top, or you can put it at the bottom. I'll show you that it works both ways. So we agree that negative 2 divided by positive 3 is negative 2 over 3. Right? You can't do negative 2 over negative 3, guys. What's that? Positive 2 over 3. All right, so if your gradient is negative, you have to put the minus at the top or at the bottom. That will also work. Because 2 divided by negative 3 again is negative 2 over 3. All right? Now, guys, from here, we're going to have to first draw our Cartesian plane and just plot our y-intercept because the counting is now going to go from the y-intercept. Okay, so we have to have that before we can do our counting. And then once you've drawn your Cartesian plane, you can put in that y-intercept. Okay, guys, now I'm going to count using both of these fractions to show you that you get the same line. You're just going to get a different point on that line, but it's fine, it doesn't matter. Okay, so from here, remember what is gradient? Change in y over change in x. So along my y-axis, which is this one, the change now has to be minus 2. You see why that's 2 down, right? Negative 2 is 2 down. So actually, I'm just going to write this a bit bigger here so that I can just write next to it what we're actually doing. So if that's negative 2 over 3, that is going to be 2 down. So the change in y, and the y-axis runs up and down, all right? So from our y-intercept, I'm going to have to count 2 units down. But then you're not going to count the point there, guys. Then you must still count 3 units. Now it's positive 3. So is the positive direction left or right? Right. So from there, I'm going to have to go 3 units to the right. And that is there where you start your point. Jesus, right? fumbling over my words today. Okay, so from there, 1, 2 down, and then 1, 2, 3 to the right. There you plot your point. Then you connect those 2 points, and that is your line. All right, we must sort of figure out what those coordinates are. So that's a very key line. I actually want to make this just a little bit longer. Yeah, because there's just one we don't know. Now at that point, I can't just leave it as a point there, floating in space. I need to say what the coordinates are. So what do we think? We went 2 units down. So what is the y value of this point going to be? -2. And I went 3 to the right. So what's the x value going to be? 3, hey? So just next to that point, you need to label it as the point 3, -2. But, like I said, you could have used the other way of writing this fraction, where you put the minus at the bottom. I'm not sure if anyone would have done that, but let's just look at it. That means that I'm now going to count +2 at the top, so 2 up, and -3 at the bottom, 3 to the left. Right? +2 is 2 up at the top, and -3, the negative direction is to the left. So guys, look what's going to happen now. I'm going to go again from the y-intercept. Remember, we always count from the y-intercept. 1, 2 up, add 1, 2, 3 to the left. Right, that point is alive on the line. It's just a different point on the line, but it's still correct. Okay, the coordinates of this point will be -3 and +2. You don't have to do both of them, guys. It's fine if that's all you have. Okay, I'm just showing you that it works if you put the minus at the bottom. What do you mean?
I thought we have to start with 3 and then the 2 on the
Okay, does that make sense? Yes. No, you don't have to. So this circle that you're drawing around it is essentially a circle. Okay, so that circle means that it's 0 on X and 0 on Y. Okay, any questions, guys? Yes. You don't have to, just if you have more than one. Right, I thought I was going to get to function notation today, but I didn't. That's fine. I am going to give you guys. Right, so if we talk about function notation, we do the graph. F of x, g of x, h of x, you know that stuff, right? It just means y. Do you remember?
Yeah.
Because now in this exercise in the textbook, they're using f and g and h. So I just want you to understand what they're referring to. Guys, I'm just going to give you a few of these graphs to draw, not many, just so that we are all fine with straight lines. Yeah.
And what
Okay, guys, you are just going to do those questions. 1A is drawing 3 straight lines using gradient intercept method, and 2A is drawing a 2 graphs using dual intercept method. This is what we're on Tuesday, guys, and then we're gonna push. All right, on Tuesday we're doing parabolas and hyperbolas on one day. Destroy then. You'll see, we can do it in one.
What about X?
That's not gonna be in your text, so we're gonna push that. Yeah, probably.
There were only a straight line around that.
Guys, if you want to hear that, I will not, check it in my planner. Okay, guys, I just need to give you information about the content of your test. Remember I told you last time it depends on how far we're going to get into functions. Yes, so it's all of circle geometry, right? You just finished that section, all of circle geometry. That includes those 3 proofs that we did. So you have to study those 3 proofs and be able to do the whole filling in required to prove construction and the actual proof. All right. So those 3 proofs that we did. And then guys, functions, which is up until the end of hyperbola. So that is straight lines, parabolas, P-A-R-A-B-O-L-A-S, and hyperbolas. There's hyperbolas. That's how you spell it. And then some interpretation of it as well, which we will talk about. So like stuff like domain and range. Yeah, we haven't done that yet. So okay. Get true. Okay. I actually forgot that we've already done 10 drops. So I thought everything was like from scratch. So there will be 3 types of graphs in your text: straight lines, parabolas, hyperbolas. Not exponential graphs. You might get to exponential graphs before the test, but you won't have it. Are we all clear on what's going to be in the test, guys? Okay. Cool, then you can pack up. This is homework for Tuesday. We're doing 8 tomorrow. If you have homework.
I don't know.
No, we were just doing terminology.
Oh, there you go.
Okay, thank goodness. That's nice.
Yeah, thank you.
That's nice. I don't know what you have.
I think we're done with graphs during terminology now. Or we have to start calculating.
Why do you have blue books?
Those were delivered years ago. So they're called blue books.